solute, which is calcium chloride or the sodium chloride, right? So all this is important, and this is the curve. This we have explained the depression in freezing point in the graph form. If you look at this graph is for solvent, pure liquid, and this is for solution, right? And this graph is coming down from A to B, then B to C. That is, the temperature in this graph is coming down, right? We are going towards here. On the x-axis we have temperature, on the y-axis we have vapor pressure. So as we come from A to B, right, the temperature is decreasing, right? And at point B, the liquid starts changing into solid form, and this point B, the temperature at this point B is known as freezing point, right? This is the freezing point of solvent. And as we decrease the temperature at B, the solid starts appearing and vapor pressure starts decreasing. We know that as we decrease the temperature, vapor pressure will decrease, because vapor pressure is directly proportional to temperature, right? So decreased, and vapor pressure decreases steeply along BC here, right, as solid have low vapor pressure. This decrease steeply here. Why? Because at B, this liquid changed into solid form, and we know that the solid have the low vapor pressure, very low vapor pressure. So this decreases steeply. The vapor pressure decreases steeply from B to C, right? Now if you look at this graph of the solution, the solution will, as we lower down the temperature at point E, this solution will turn into solid form, right? And if you look at point E, the temperature is TF, right, which is again the freezing point of this solution. And we know that this TF is less than TF0, right, which shows that the freezing point of solution is less than the freezing point of pure solvent, right? On cooling, solution follows path DE. At E, the solid appears at this point, and E represents the freezing point TF of the solution, and we know that TF is less than TF0. This is depression in freezing point, and the difference between these two is delta TF, which is depression in freezing point, right? So it is clear from the graph also now. So delta TF is equals to TF0 minus TF, which is the depression in freezing point, right? So I hope all this is clear. This formula is important for numericals, right? And in this formula we just calculated the molality, the expression for molality, and substituted its value here, right? And from there we just solved it for the molecular mass of solute, right, which is this, and this is the expression, right? Molecular mass in terms of depression in freezing point, right? So I hope all this is clear to you. Thanks.